Welcome to the third and final lecture in our series on the experimental method. For those of you keeping score, this is topic 1.3 in the College Board's course description for AP Psychology version 1. My name is Chris Gall and I wrote today's lecture. Specifically in today's lecture, we're going to look at the difference between random assignment, which we covered in the previous lecture, and random selection, particularly when we were talking about the differences between experiments and correlational studies. The learning target, as defined by the College Board for today's lecture, is that you can distinguish the difference between random assignment of participants in experiments and the random selection of participants for correlation studies and surveys. In English, that you can explain what the difference is between random assignment and random selection, and that you can explain why random assignment is used in experiments and random selection is used for surveys and correlation studies. There are two major topics to this lecture, random assignment and random selection. Random assignment we've covered previously. In essence, a group of people is pulled off the street to participate in a psychology experiment, or more typically in my experiment, a random group of psychology students who were being required to participate in a given number of experiments for a grade for their Intro to Psych class. Then those folks are randomly split into two groups, one who gets experimented on, zapped in what I said in the previous slide, right? That's the folks who are getting subjected to the experimental treatment, and a group they are being compared to, who are not being subjected to the experimental condition, whose variable is not being changed. Okay. Unlike random assignment, random selection is about who is in and who is out, who is allowed to participate in the study and who isn't. The entire purpose of using random selection is to minimize the differences between your study population and the general population. This allows any results you might get to be generalized to the entire population as a whole. Think about it this way. If we want to survey the population of Todd Beamer, I can literally track down and talk to all of the students. But would that ever be a pain in the keister? If I do that, I can get results that clearly apply to the population of Todd Beamer. But I also spend a lot of time and money doing it. Or I can select a subset of the population from Beamer that mirrors its demographics. The same percentage of males and females, of 9th graders, 10th graders, 11th graders, and 12th graders, of white kids, black kids, Asian kids, Latino kids, Native American kids, and mixed race kids. If I do that, and then I can say that my results will generalize to the population, right? The best way to do that is to randomly select a group of kids at Todd Beamer. If I do that successfully, then I can generalize my results from my subset of the population to the entire population. I don't actually have to survey the entire population. I can survey just part of it. This is a lot cheaper and faster to do. And like I said, because the differences are essentially minimal, then you can treat the two groups as essentially the same in terms of results, right? The big population and your subset. You can think of random selection as a way of controlling variables. In that sense, it is similar to random assignment. So we've reached the end of our lecture. To determine if you successfully understood what you needed to for this lecture, ask yourself if you can do a few things. First, can you explain the difference between random selection and random assignment and where you might find each? Then ask yourself why random assignment is used in experiments and why random selection is used for correlation studies and surveys. If you can answer those questions, then you've successfully completed this lecture. Random assignment is when you need to minimize the differences between groups. Random selection is when you need a small group that mirrors a larger group. Because correlation studies, and the surveys often used to conduct them, are not worried about establishing cause-effect relationships, you're not looking at one small group. You are only looking at one small group. Thus, the goal is to minimize the differences between that small group and the population it is supposed to represent. Random selection helps to do that. Random selection can be accomplished by doing something like picking every third name off of a list, if you wanted a subset of 1/3 the size of the original population. Everyone on the list has an equal likelihood of being included. If you did not understand any part of this lecture, please go back and rewatch all or part of it. If you did, but still have some clarifying questions, please feel free to ask them during class. Until then, so long and good night.